Factoring binomials, take 152. Today we're going to factor binomials. This is a great skill when it comes to solving quadratic equations and you don't have your calculator and can't just graph it and find the intercepts. It's also kind of fun and it's going to play right off of what we did in class yesterday. What I'm asking you to do is take these back to the expressions that it came from. Which binomials multiplied to give us x squared plus 7x plus 12? Keep in mind that when there's no coefficient written in front of the x, there's actually a 1 there, which is really important. We're going to discuss that in a couple of minutes. You know that the only way we're going to get x squared is by multiplying an x and an x. The 12 is a little trickier. We have a number of options. We could put in 12 and 1. We can put in -1 and -12. We can put in 3 and 4. We can put in -3 and -4. We can put in 6 and 2. And we can put in -6 and -2. We have to decide which is our best bet. Now, this is the point where I'm going to ask you to look at your second number for a clue. First of all, notice that it's positive. When you see that, pretty much you can readily cross out any of your negative options. What you want to do then is think, when you have 1 for your lead coefficient, you know that the two numbers you choose to multiply to 12 must also add up to 7. When you know that, it's really easy for us to decide that it's 3 and 4. At this point, I can write them in either order. I can put the +3 here and the +4 here, or switch it up. It doesn't matter. What is important, though, especially when you're first doing this, is that you check your answers every time. You can use FOIL, the area method, or distributing. Just check it. I'm going to use distributing, and if I do x times x, I get x squared. 3 times x will give me 3x. 4 times 3 is going to give me 12. And 4 times x is going to give me 4x. When I add those up, I notice I do get 7x as my middle term, so this totally checks. Now, a related problem, which will use our same numbers, is the one lower on the page, x squared minus 7x plus 12. Now, you're going to start with just the same x's at the beginning of each of your binomials. Now you've got to find two numbers that multiply to 12 but add up to -7x. Very similar to the one we just did, this is just going to be -3 and -4. Again, I can write them in either order, it doesn't matter. And you can FOIL it out and see that that will also result in a middle term of -7x. To check it. If you want to see that again, please hit the rewind button. Okay, our second example, this one isn't quite going to be so simple. We have a coefficient of 2. So we're not going to simply be able to add up our two factors and get 7. The 2 is going to throw us off. It's not quite as hard as you think, because basically there's only one way you're going to get 2x squared. That's by multiplying a 2x and an x for our first term. And when we think about 3, we can multiply 3 and 1, or -3 and -1. What we don't know is which one goes in which space. We could put one here or here. When we look at our second number, we still get a big clue that we're going to be looking at our positive options. We can get rid of these. What we don't know is, does the 3 go with the 2x, or does the 3 go with the x? So let's just start it here and see what happens. All right, here's where I encourage you to check. You would, 2x times x is 2x squared. 3 times x is 3x. 2 times x is, or 2x times 1 is 2x plus 3. This is going to give us 5x. It doesn't work. Nope, back to the drawing board. So let's go back, switch these out, put the 1 here and the 3 here, and check it again. We're still going to get our 2x squared, and we're for sure still going to get our 3, but our middle terms this time, excuse me, are going to give us plus 1x and plus 6x. Magically, we got our plus 7x that time, and it checked. If you want to see that one more time, I strongly recommend you hit the rewind button. All right, we had a little bit of experience in these yesterday, and some students recognize that there is a pattern. There is a specific pattern that yields no middle term. This is called the difference of two squares, and it is only possible when you have opposite signs, as in this case, -7 and +7. Just that easy. If you're not believing me, go ahead and check. You're going to get x squared minus 7x plus 7x minus 49. Please note, this only works when you have a negative. It is called the difference of two squares. And it's really super handy. You can try that for y squared minus 25, n squared minus 144. It's always going to work. We have one final example before I see you in class, and this is just what we did before, but in 2 steps. Before you try and factor it, what you might want to notice, and this is helpful, look at your lead coefficient. See if you can factor that out. What I'm asking you is, does 3 go into every one of these terms? If it does, you can save yourself a lot of work by taking it out right at the beginning. Divide each term by 3. You're going to be left with x squared minus 6x plus 5. You're doing the opposite of distributing here, but it's going to make your life a lot easier. Now that the 3 is out of the picture, you can factor it just like we did the earlier problems. There's really only one way, well, 2 ways to get 5. And your middle number as a clue is telling you you want your negative option, so let's get rid of these. And write in -1, -5. Let's double check. X squared minus x minus 5x plus 5. That totally is going to give us our answer of -6x. Everybody goes home happy because it works, and our solution is right here. You can't ignore the 3 once you divide it out. It's got to stay, but it makes factoring a whole lot simpler. That's about all we have. We'll do some more of these in school and bring in some nice notes. Have a nice evening.